All right, let's do it. So, animal testing. So to start off, talk a little bit about genetics. Humans are 99.9% genetically similar to one another, and chimps are our closest living relatives, sharing 98.8% of genetic building blocks. Dogs, 94%, and cats are 90%. Not pictured here, but mice are 97.5% similar to humans, just 1% shy of chimps. Mice represent approximately 98% of animals used for scientific research, and it's important to note that genes make up just 2% of DNA. Therefore, something that's 60% similar to you, like a banana, may only share a fraction of your DNA. There are many brands, and that almost all of the cosmetic companies that have been approved for human use were tested on animals. You may even recognize some of these brands like Neutrogena, Dove, and Olay. But for the majority of these cases, these brands are sold in China, where animal testing is mandatory by law for foreign cosmetics. Unlike China, the US, the FDA does not require the use of animal testing for cosmetics. However, it is not banned in the US, as it is in the European Union and the UK. Some ethical issues. 50 million animals are used in US laboratories every year for chemical, drug, food, and cosmetics testing. The Animal Welfare Act sets standards of treatment for animals used in testing. However, mice are not protected under this act. And, again, 98% of animals used for scientific research are mice, with less than 1% being dogs, cats, and monkeys. Because rodents aren't covered under this act, they are at risk of being poorly treated, such as not being provided pain relief or being killed by asphyxiation, neck breaking, or decapitation. Some researchers argue that rodents are ethically treated because of the requirements for the treatment of animals in order to receive the funding that these institutions require to be able to conduct scientific tests. Some impacts on the environment is there's a lot of waste from the 50 million animals. And even though that there are incinerators for the animal carcasses, there are still bedding, cages, needles, and syringes that need to be disposed of. And this waste contains drugs and chemicals that may have unknown toxicities, which can cause air, water, and soil pollution. But animal testing does help save lives. These are a small selection of major medical breakthroughs made possible through animal research. Diseases like polio, tuberculosis, COVID, and even organ transplants and Parkinson's all have been helped with animal testing. If these treatments were used to save or improve lives of millions of people. In 1952, 60,000 children were infected with polio, resulting in 3,000 deaths and thousands more paralyzed. With the development of the polio vaccine in 1955, the disease has almost been eliminated from the world today. Despite these medical success stories, an overwhelming majority of these experiments do not contribute to improving human health. There's a very high failure rate in drug development. Approximately 92% of drugs fail according to the FDA. The main reasons for failure are lack of effectiveness of the drug and safety concerns. One reason a drug may not be effective has to do with the differences in genetics and physiology between humans and animals, making animal testing a poor predictor of effectiveness in humans. Another reason is the complexity of human diseases and the difficulty of applying that to their animal counterparts. One counterargument is to view the 10% success rate as effective because there is no better alternative. Otherwise, why would these companies spend billions of dollars and 10 to 15 years on research if there was a cheaper, quicker alternative? However, there are several alternatives that show promise, like cell and tissue cultures, human-derived stem cell models, computer algorithms, and microchips. These alternatives are cheaper and faster than animal testing, and it's not surprising that these alternatives are being used whenever possible. But these alternatives are not yet sophisticated enough to replace animal testing, because only animals can demonstrate the effects of disease, injury, treatment, or preventative measure on a complex organism. Various conditions such as high blood pressure and blindness cannot be tested using stem cell cultures, for example. The organ on a chip is a promising technique that can help emulate the physiological environment and functionality of human organs on a chip or disease for drug testing. Organ on a chip contain engineered tissues derived from various organs that are grown inside miniature fluid chambers modeled into glass or silicone. Though simpler than human organs or tissues, they are effective mimics of human physiology and disease. It shows great potential for revolutionizing the drug development pipeline, offering greater physiological relevance and complexity while offering greater effectiveness than the animal model. In conclusion, animal testing is the most effective method that exists today to help find cures and vaccines. But there are ethical and environmental drawbacks, like testing for cosmetics should be banned in the United States because it has little to no benefit to humans besides making us look pretty. And animal testing should be limited to life-saving treatments where no alternative exists. Thank you.
All right. A couple of questions. How valid and reliable are the sources you used? How do you know? And which sources didn't work?
I think that my sources were very valid, and when validating them, I tried to figure out which sources were better than the other ones, just trying to figure out what the websites were and like their biases. This is just crazy. Yeah, wait. Sorry, can you ask the question again?
Sure. How valid and reliable are the sources you used? How do you know? And which sources didn't work?
Sorry. I think many of the sources out there are biased since mice and rats are excluded from statistics, so it's hard to nail down like a real number of animals. And extreme advocacy groups like PETA and private research institutions, which are selling like their genetically modified mice, both will give out like extreme highs or extreme lows for like numbers. So it's kind of hard to find like real like mainstream sources. But I looked at Stanford was one of the sources I used, and the USDA annual statistics.
Okay, thank you. What advice would you have for other researchers who consider this topic?
I would say be wary of the biased sources and be skeptical and make sure that what you're reading is not coming from like a source of like economic gain or a political advocacy group. And it's important to read from a variety of sources in order to reach your conclusions.
Okay. All right.